This one here looks like a u sub. I would have chosen u squared instead of just u. So u squared equals to 9 take away 4x squared. 2u du equals negative 8x dx. There's your x dx. Divide by negative 8. You will get what? Negative u du on 4 is equal to x dx. Next line becomes negative a quarter on the outside. The top, instead of x dx, becomes u du. The bottom is the square root of u squared, which becomes u. U will cancel out. Integrating du is just u plus c. So the answer we're looking for is negative square root of 9 minus 4x squared on 4 plus c. Anyone want to check if they've got a 1 out of 2 or a 2 out of 2 or a 0? Anyone to check anything?
Like Sam, I thought this was a sign.
Sign?
Yeah.
It does not become a sign because there's still an x on the top. So an inverse sign was it would have been a 1 or a 2 or whatever. It would have been a constant. So unfortunately, if you did just write inverse sign, you missed that. You missed that. Nah, yeah. If you wrote inverse sign, it's got to be 0. It can't be a 1. Anyone else want to double check anything? That's a shame for the inverse sign. Oh well, it happens. Completing the square. This one here, I think we know probably becomes an inverse tan, but let's just quickly do it. X minus half of 6 becomes 3, and then you have subtracted 13, added the 9, so plus 4. And then this should become, if you follow the inverse tan rule, it's 1 on A, so 1 on 2, inverse tan X on A plus C. If you didn't write the half, you'd lose 1 mark. Otherwise, if you completed the square correctly, you'll also just get 1 mark. So if you completed the square, that's 1 mark. If you actually got the full answer out, that's 2 marks. If you missed the half, it's still 1 out of 10. All right, all good. This next one, partial fractions, worth 5 marks. Let's get this one out. So these ones, again, I think we know by now what we've got to do. You're equating a numerator. So with I, 16x take away 43 equals A, and then what's missing in your denominator compared to your common denominator, you're missing an x plus 2, plus B, you're missing an x minus 3 and a x plus 2, and then C, you're missing an x minus 3 squared. Then the first thing I would have said to you guys is always try to get rid of your x equals 3 and negative 2 cases, so where your coefficients are 0. So x equals negative 3 and x equals positive 3. And x equals negative 2. So when x equals 3, that's gone, you're going to get 5a. Here you'll get 48 take away 43, which is 5, so you should get a equals to 1. Learn to box it, so it's easily identifiable. X equals negative 2, gone. Negative 2, negative 3, negative 5 squared is 25. C. Let me know if I'm making any mistakes as well. Negative 32, negative 75. So C equals to negative 3. And then the last one, which is to find B, you could have just said let x equal to 0. You could have said equate coefficients, which is what I'm going to do. So you could have done let x equals 0 as well. Equate coefficients of x squared. So the left hand side is 0, That doesn't have anything. That one's a B. Plus, this would be a C. We know C is -3 when I bring it over. 3 marks, 1 mark for each. So if you got all three, 3. If you got 2, 2. If you got one of them, 1 out of 3. All right, any questions? Hence, find this. All right, A plus B minus C. I like to write plus and then -3 on x plus 2, so that way you don't really make any mistakes. These are usually pretty easy for a lot of students because they buy at this stage of year 12, especially. A lot of things are going to be logs. So there it is, 3 log x minus 3 minus 3 log x plus 2. This one here is just normal integration, and that's what a lot of students do miss. So this one's just going to become x minus 3 to the power of -2, and then when you integrate that, that becomes x take away 3 to the power of -1. You add 1 over the power, and then you're pretty much done. So you could have left it like that, you could have simplified it, doesn't really matter. I might just be a little bit fancy, so you guys remember how to use your index, your log laws. If their coefficients are the same and they're subtracted, we can divide your inside. So x minus 3 on x plus 2. Plus. So. All right. Any questions for that one? Either one, if you had left it in this top one, full marks, or the second one is full marks. No, still good. Okay. D. I think we know what we've got to do with D. 5 parts. Again, we follow that laity rule, so U, du, dv, and v. U is equal to t, du is equal to just dt, dv would be e negative t dt, and then the integral of that is negative e negative e negative t. Yep, that's it. Integrate that is e negative t, stays the same, and then differentiate, and then yep, perfect. Okay, any questions about that step? Integrate, so I equals, if this is I, this and this minus these two, so negative t e negative t, negative t e negative t. You've got limits, so you've got to include the limits, minus these two multiplied together, so negative and negative makes it a positive, and then integral from 0 to 2 e negative t dt. Next line, this becomes -2 e negative 2. When you're going to sub in 0, that just disappears, so you can ignore that. Plus, we're going to integrate this, which we know becomes just that. The limits, and it's just a matter of finishing it off now. All right, any questions? -2 minus 2 is -4, and then that becomes 1, -1, +1. Anyone get this out correctly?
Yeah.
Ezra, good job. Anybody else in here? Yeah?
Yeah, I got it.
Yep. Greg?
I didn't do D, but I did E because I
Okay,
ran out of
okay.
time.
Sure,
And
sure.
yeah.
Sure. That's fine. Queenie, Rosemary, what about you two?
I didn't get it.
You didn't get, like, did you realize it's a by parts at the beginning though?
Yeah.
Okay, and then what part did you get stuck with?
I think I just messed up when I wrote it out or something.
Did you get your first line out?
Yeah.
Okay, that's interesting. And then what? And then the second line, did you realize the limits?
Yeah.
Okay, where did you go wrong? You would have subbed that in, I'm assuming. You would have integrated this. What, just towards the end, maybe?
Yeah. I don't know.
All right, when you see this, do you feel like, yep, okay, I know exactly what to do?
Yeah.
Okay. And Rosemary? No, mic's not working. Rosemary, here she is. Yeah. Okay. Rosemary, just type so I know you're here. Yes. E. Well, at least you can hear me. E. Let's try this. Did you get this one out, Greg?
I got this one out, yeah.
Yeah. Cool. All right. Use the substitution t equals tan theta on 2. So this is obviously a t formula substitution. So the way we do these, if you guys remember, we first have to write t equals tan theta on 2, and unfortunately we can't use this. Your text is working, but I can't hear you. So maybe try now, Rosemary. No, can't get you out. Theta, theta is the one that we want, not t. So what we've got to do is obviously, because you want to get rid of d theta, right? Think of it like that. So what you want to do is obviously make theta a subject, so you inverse tan times 2, and then from that line we are differentiating. So we're going to get 2. The derivative of inverse tan is 1 plus t squared, right? Because we know the integral of 1 plus t, 1 on 1 plus t squared is inverse tan. So the derivative of inverse tan is 1 on 1 plus t squared. There's your dt. Integral of theta is just going to be your d theta. That is just a constant step that you pretty much have to memorize. From that, you obviously have the fact that you know what sine theta is using your triangles, and that's your theta. Sine theta is opposite over hypotenuse. So sine theta is equal to 2t on 1 plus t squared. And I think the last thing we've got to do is just change our limits, yeah? And then we're done. When theta is equal to 2 pi on 3, theta is equal to pi on 2, t is equal to, t is equal to. So pi on 2, that now becomes tan 45, which is 1. The next one is tan 60, which should be root 3. Again, let me know if I'm doing something wrong. Therefore, your integral is root 3 to 1. D theta, which we write like this. We write divide sine, which is 2t on 1 plus t squared. Right, I'm going to pause there. Any questions regarding where we've got up to by now? No? We're happy? This and this will cancel out. This and this will cancel out. This will go in the denominator. So you're pretty much left with what? Integral of 1 on t dt. This becomes a log. Log of 1 we know is 0. So the only answer you have is log of root 3, which is of course half log 3, which equals to the right hand side. Exactly as required. So that wasn't actually too hard for a last question in the question 1. Let me stop the recording and then we'll talk about